Alright dear children, let's continue with the same chapter, matter wave. Now in this particular YouTube video, we specially derive the expression of de Broglie wavelength of one of the matter particle, electron. Okay. Now electron can even make to move with a speed almost comparable to the speed of light, means less compared to the speed of light. Okay. But when this electron move having certain mass, move with a certain speed, then it can also acquire some wave nature. Okay, just like a light can travel from a source, can acquire wave nature. Okay, now for that, in order to measure the wavelength, so let me just consider first the electron which has mass. So let m be the what? I'm considering let m be the mass of the electron. So I'm taking electron as one of the matter particle whose mass is m. And I consider that electron is moving with a velocity b. So what is b? B is the velocity of the electron. But as you know, this electron velocity is less compared to the velocity of what? Light. Now, as for the relation which we derived in the last YouTube video, de Broglie wavelength can be expressed by lambda equals to h by mb. See, in terms of mass and velocity, and this is also called momentum. So de Broglie wavelength lambda equals to h by mb. See, this is the expression that we follow. But you know, electrons are in a state of motion. Then, and you have learned that moving mass, a moving particle only execute what? Associated with what? De Broglie wavelength. So that means this moving electron acquire what? Energy also. And that energy is called kinetic energy. So that means there is a kinetic energy of the electrons also. I don't know, therefore, what energy? Kinetic energy. So the kinetic energy of the electron, that is k equals to half mb square. So what is the expression? Half mb square. Because kinetic energy having mass, a body having mass moving with the velocity is given measure as by the kinetic energy, and the kinetic energy is equals to k equals to half mb square. Okay. Now from this expression kinetic energy, I'll make b as the subject. Let me just cross multiply. So I can write 2k, 2 and k, I'll multiply 2k by, now this m I'll bring the denominator. So 2k by m equals to b square. So if b square equals to 2k by m, then b equals to square root of 2k by m. See, b equals to square root of 2k by m. So this is the velocity that can be expressed in terms of what? Kinetic energy. Now this velocity expression, expression of velocity I substitute in the expression of wavelength, and that is called de Broglie wavelength. So look at it. Lambda equals to h by m. Now this b means this one. So I replace it by square root of 2k by what? M. Okay. Now this m is inside the square root, so I can split this in this way also. M, okay, I write on square root of 2k by square root of m. Okay, square root of what? M. Now this square root of m will be reciprocal. So h into square root of m by, there is m, but there is square root of m in the numerator. So what I do, this m can be even written as square root of m into square root of m. And there is already square root of what? 2k. So children, look at this expression part. M means square root of m into square root of m. Means square root of m into square root of m can be written as m. So that this square root of m and 1 square root of m cancel out. So lambda equals to now h by, now this square root of m and this square root 2k, so I write in whole square root 2mk. See, m is also inside the square root, 2k is also inside square root, so I can write a common square root with 2mk. So finally you can see the expression of de Broglie wavelength. This is actually for the electron that we are measuring. Okay, so lambda equals to h by square root 2mk. Lambda equals to h by square root 2mk. Means we can measure this expression of de Broglie wavelength in terms of what? Kinetic energy. Now I consider this expression as a general expression of de Broglie wavelength. Okay, it's not only the expression we can measure for electron only, it can be measured for what? Proton also or neutron also. Because the only thing that we need to keep in mind is, if you measure for electron, this m must be taken as the mass of electron. If you measure for proton, this m must be the mass of proton. If you measure for neutron, and this m must be the mass of what? Neutron. Okay. But children, let's come to the particular case. And the case means we are actually deriving the expression of a de Broglie wavelength, especially for which particle? Electron. So what I do for electron, if I take particle only as electron, okay, now this electron can acquire energy, kinetic energy, and in order to acquire kinetic energy of electron, there must be some source which supplies some potential difference or some voltage, okay, and due to that potential difference of voltage, the electron acquire what? Kinetic energy. Because children, you have learned that the kinetic energy can also express in terms of what? Potential. Okay, you have learned kinetic energy also in terms of what? Potential. So for the electron, when having certain charge, this electron can also acquire kinetic energy, and this kinetic energy can also be written as K equals to E into B. So look at the expression, K equals to E into B, where E is the charge of what? Electron. And B is the potential difference. B is the potential difference that is applied across the end. So children, kinetic energy can also measure in terms of charge and the potential difference, because by some potential difference the electron can move with according to a certain kinetic energy, and that kinetic energy is given by E into B. So this K I can replace by EB also. So write down lambda equals to h by square root of 2m. Now this K I replace by what? EB. So lambda can be able expressed by this expression. So lambda equals to h by square root of 2m EB. But the most important part in this expression, if you see children, is they are the physical quantity whose value are basically known. H, Planck's constant, we know it. Mass of the electron is also constant, which is known. Electron charge is also known. So if I substitute the value of H, M and E in the expression, we can measure this potential energy or de Broglie wavelength directly in terms of what? Potential. That means de Broglie wavelength can be measured directly in terms of potential difference also. So let me substitute the value now. So H, the Planck's constant value, basically we take as 6.63. Let me take in two decimal place, 6.63 into 10 to the power what? Minus 34. Okay. Whole divided by square root of 2 m. M is the mass of the electron, and you know mass of the electron is basically 9.1 into 10 minus 31 kg. E means the charge of electron, and charge of electron basically 1.6 into 10 minus 19. With B, I write on B only, because this potential can change. It can be any value. Okay, that's why it's not particular fixed value. That's why we can measure this wavelength in terms of potential. So for simplifying this expression, okay, so let me just do the simplification. So let me write 6.63 on the into 10 to the minus 34 whole divided by square root of, now this quantity now we can multiply. Children, now see 2 into 9.1 and 1.6. If you multiply the three quantity with the calculator, you get approximately say 29.12 into, now these are the exponent with power minus 31 and minus 19. This power will be added. So I write on 10 to the minus 50, 10 to the minus 50, and B. Okay, now let me take the square root of denominator. 6.63 into 10 to the minus 34, okay, whole divided by the square root of 29.14. If you calculate with help of calculator, approximately you get 5.3963 approximately, into square root of 20 minus 50 means definitely half of this, that is 25. Now I'll keep the square root of potential inside as it is, square root of B only. Okay, now we can take this power in the numerator. So I'll add 6.63 into 10 minus 34. Now minus 25 if I take in the numerator, plus 25 by how much? 5.3963 with square root of what? B. Okay, now let me subtract this quantity, 6.63 into 10 power minus what? Minus 34 and minus 25 means basically minus 9 by 5.3963 with B. Now we can divide 6.63 by 5.3963. If you divide with the help calculator, you get approximately 1. How much? 227. Approximately I am writing in 3 decimal place with 10 to the power minus 9 by square root of what? B. But children, I write this value in the order of power 10 to the minus 10 because this wavelength which we measure is basically in meter. But I write the wavelength in the standard unit, and the standard unit is what? Armstrong. That's why children, we can measure directly wavelength in Armstrong. Okay. So to keep this minus power 10 to minus 9 as 10 to power minus 10, so I shift this decimal to 1 decimal right, because if the power is negative, if you shift 1 decimal right, power increases by 1. So it will be 12.27 and with power 10 to minus 10. So power will be 10 minus 10 by square root of B with meter. Okay. Now 10 to the power minus 10 meter, what? This is equivalent to 1 Armstrong. So 10 to the power minus 10 meter is equivalent to 1 Armstrong, which means 12.27 by square root of B, and I replace directly by Armstrong. So children, look at the relation, and this is the relation we can use directly in numerical problem to calculate the wavelength directly in Armstrong, which is lambda equals to 12.27 by square root of B Armstrong. Means if you know the potential difference, if the potential difference is given and calculate the de Broglie wavelength, if you are asked to calculate the de Broglie wavelength, we can directly measure the de Broglie wavelength by using this formula. So this is the expression that we use to measure de Broglie wavelength of electron. So we have completed the theory part of this chapter. Okay, so one topic which is actually not in the syllabus, as per reduced syllabus sent by Council, experimental demonstration on de Broglie of matter wave. Davidson and Gramer experiment on electron diffraction is not in the syllabus. But for your information, children, I'm just telling you, this de Broglie hypothesis was actually verified experimentally by these two scientists called Davidson and Gramer. Okay, it's basically the experiment which they performed to observe diffraction pattern observed with the electron. So electron also get diffracted. Electron as a matter particle can also get diffracted. Okay, and electron diffraction is based on the verification of what? De Broglie hypothesis. Okay, de Broglie hypothesis. So I have explained in details with the theory part of this chapter. Now in the next YouTube video, you learn the numerical problem. The important numerical problem based on the expression, different expression that you learn from this chapter.